Hello, 1,500 students. This is the first time you get to see and hear me, Dr. Lamb, and I am working my way through the Scientific Methods Lab, which is on page B1 in your lab manual. Please have that open, and if you don't have your lab manual, please go to D2L and open up the file for scientific methods, which is there under content. No, excuse me, under assignments. Right? Go ahead and pause the video while you do that. The students, not you. And then when you're ready, start the video again. Ready? Okay, let's go. So in this lab, we're talking about the scientific method, where we are testing a hypothesis. What's a hypothesis? It's an educated guess formulated in a way such that it can be disproven. In other words, it can be shown to be wrong by the evidence. This is an important thing about science. Science is not logic, it's not philosophy, it's not geometry, where we try to prove something using a series of rules. That's called deductive reasoning. In science, we use inductive reasoning, where we try to develop the rules from the evidence. So in this case, we're testing the hypothesis about which is more important in the energy of a moving object, which is called kinetic energy, the mass of the object, is shown here by these different size balls. This is more massive, this is less massive, or the velocity. Now, what makes this an educated guess is that Isaac Newton wrote out the formula for this back in the 1600s, almost 400 years ago. And his formula for this was kinetic energy equals 1/2 times the mass times the velocity squared. So we can figure out based on that equation which is the educated guess or the educated answer. It should be velocity. If you don't believe me, I'll go run through the math for this. So let's start off by putting ones in for the mass and the velocity. So in that case, with a velocity of 1 and a mass of 1, it becomes 1/2 times 1 times 1 times 1. All those ones multiplied together just equal 1. So it becomes 1/2 times 1, which means it's 1/2. The kinetic energy then becomes 1/2. What happens then if I double the mass first? Well, then you stick it in the equation, it becomes 1/2 times 2 times 1 times 1. Again, those two ones just equal 1, and it becomes 1/2 times 2, or 1. Double the mass, double the kinetic energy. That's fairly straightforward. Now, what about the velocity? Stick that into the equation. So that now becomes 1/2 times 1 times 2 times 2, which becomes 1/2 times 4, or 2. Double the velocity, the speed at which an object is moving, including its direction, and the energy increases 4 times. It quadruples. So we're going to test both of these. But before we do that, I want you to go to your worksheet on either in the lab manual which you're able to get, or on the worksheet you're able to download from D2L, and write down first, which is more important, mass or velocity. If you have you can have your choice of either circling velocity or writing it out. Do that. Pause the video. Come back. All right, you're back. Now, at the very bottom, it says, write this out as a hypothesis. That means it's a statement about which you think is more important to the kinetic energy, the energy of motion of an object, the mass, the velocity. So write it out in such a way that you can say that velocity is more important. Write that out. Once you do that, okay, come back to the video and then turn the page. All right, so before I drop these balls, I want to point your attention to the next 2 questions. The first one is, what assumption has to be true in order for this experiment to work? And that is that the idea that the greater the energy, the bigger the volume of the crater. We're testing kinetic energy by dropping ball bearings into some cat litter. Don't worry, a cat has never touched these things in more than 20 years. And so let's see if that works with masses. This is the small ball and this is the large ball. You can see how much different it is. This is easily 10 times more massive than this. All right, it should have a lot more energy. So let's go watch these balls and watch the craters they dig out. Notice I dropped them from the same height. That means that, and you saw that they fell and hit the cat litter at the same time. You can go look at them. It's a little, by tipping it over, I filled in a little bit, but I can go measure these for you. The small balls crater is about 8 millimeters across. The large balls crater is almost 10 centimeters across. And also, we'll go uncover the balls, because you can see the difference. It's going to be good. Stand up. I'll take my hat off. You get to see my bald head. And that's about 1.2 centimeters deep. Let's do the same thing on the other one, on the large ball. And that's more than 2 centimeters deep. The large ball dug out a larger crater. It had more energy. It threw aside more cat litter. Okay, so that shows that, at least in this demonstration, what I told you about this, well, for this to work, works. The more energy, the bigger the crater. The next question says, is there a confounding variable? What's that? A confounding variable is one that we haven't controlled for that may have an influence on the variables we are controlling for. We're controlling for velocity. We're dropping these balls from the same height, which means they'll hit the cat litter at the same velocity, same speed, and we're controlling for the mass. You know, you're going to see that I've got, in a later video, that you're going to see that I've gotten the masses of all these things. But I'm not controlling for the one thing that increases the mass, which is the size of the ball. All these balls are made of the same material, stainless steel. These are stainless steel ball bearings. And the only way you can make the same material have more mass is to have it bigger. That means that the size of the ball is not controlled for. Now, how could we, so therefore, this may have effects, because they increase size, that may amplify or make greater the effect of the mass. Now, how can we control for it? Well, we can have balls of the same size with different masses. That would require me ordering balls that are the same size, made of different material. In other words, I could get a ball like this and order it made of aluminum. And if I really want to get fancy, that would be a light ball. If I want to make a heavier ball, I could order one that's made of lead and coated with stainless steel. Yeah, I'm not going to do that one. All right, and it's not like I'm going to let you be exposed to, lead. That's dangerous. We here in Michigan have found out the hard way how dangerous lead is. All right, but that would work. I mean, you can say, well, what about wood? If I made it made of wood or plastic, the problem is that it would be so light that air resistance would slow it down, and that would be an additional variable that would mess it up. All right, it only would work in a vacuum. So write down, the whole idea of, that the size of the crater has to be proportional to the amount of energy. That was, the more energy, the bigger the crater. And write down that the confounding variable is the size of the ball, and you would have to have balls of the same size but different masses. All right, we're going to stop We're going to go on to the next video right here. So go on to the next video.